Good morning and welcome to this webcast dedicated to our partners, where we will show the presentation held in Vegas at the HxGN Live 2019 on where we presented the new scenario with Rheticus and the predictive analytics we create in support of the predictive maintenance of the utilities network. So in my presentation, I went quickly through the presentation of Planetek, underlining that our experience in Earth observation, location-based system, and data interoperability, together with our deep knowledge of space software, all combined together, and with our long experience in the exploitation of geospatial software, have been mixed in order to support all the operation with Rheticus and supported the achievement of the latest exciting results of our platform. So in this presentation, we will see what is Rheticus today, how we we support the utilities companies to solve their problems and meeting their challenges and their needs, and we will see the group hierarchies where we have provided predictive analytics in support of their maintenance for the utilities network. And at the end, we will look at the map portfolio and the support it gives to our operation. So let's go quickly through Rheticus, what is today, where we're going. For those of you who are not familiar with it, Rheticus is the platform we use to acquire data continuously collected by different satellites for the constellation of the European program Copernicus, which are available worldwide and can be used for any kind of application by users all over the world, but also from other constellations like the Landsat operated by the USGS, private constellation operated by private satellite provider. All this data can be downloaded and processed by our Rheticus platform, which is a cloud computing environment for the continuous access to satellite data and other geospatial data and not geospatial data, the continuous processing and the creation of a continuous flow of information, which is then consumed by M.App Enterprise to create vertical application and vertical smart maps for different markets. One example of the monitoring we can do with Rheticus is the terrain displays monitoring. We do with the time series differential in s.r.l techniques. We use radar data which after every pass can help us recognize targets on the Earth's surface, and if there is a subsidence movement, which means a problem in the ground going down over the area of interest, if we recognize this target in each passage, from one passage to the other, we can measure the distance between the satellites and the target on the Earth. We measure these distances with a millimetric accuracy, and so every time the satellite passes, we can see with our very sophisticated algorithms based on the s.r.l processor developed by our scientific team of GAP, we can recognize targets which present a high level of terrain displacement. High level means that we are talking about millimeters per year of something which is supposed to be stable and instead it moves. So we can have maps with a huge density of dots corresponding to these targets identified automatically by our algorithms. And whenever we query one of these targets, we can see the displacement trend along the time series. This is a technique for monitoring which is state of the art. So wherever we found this kind of problem, of a displacement problem, there is something real happening in the real world, like in this case where you see a joint which is broken in a motorway. With Rheticus, we provide this information which are updated every month. So as a result of this monitoring, you can access a web application on the web with a map with dots thematized in base of the displacement, as you can see here on the bottom left of this web interface. Red dots means that they are points which are moving down with a high speed, more than 10 millimeters per year. Blue dots means points which are moving up or moving towards the direction of the line of sight of the satellite. This way we can really monitor displacement of the terrain, which is of course very useful to control the monitoring, to control the stability of infrastructure, utilities network, and whatever is made by humans on the Earth surface. This information are all available in Earth imaging, so this is easy to understand how we can provide information we can be consumed by the web application of Rheticus displacement, can be consumed by third-party software, in this case like Earth Imaging 2018, can be consumed by smart maps, and this is the way we create vertical services and vertical solutions. I made an example with the radar data. Let's see an example with the optical data. Again, with Rheticus, we can analyze a long series of Sentinel-2 data, in this case, optical multispectral data collected over the zero interest in long period of time. And with the algorithms of Hexagon Geospatial, we can classify the different coverage of the land in this specific area. And we can automatize this process using the machine learning algorithms provided by Hexagon Geospatial. As a result, we will have maps which will be always updated with the different classes of land cover, which is important not as such, not as a map, but it is important in terms of the analytics we can derive and which help us understand how the land is changing as we update this information every month. So you can easily understand how the importance of the monitoring we do with Rheticus is not just in creating maps, but it is in creating indicators which tell us a story about the trends in the changes of our Earth. This way we create application with Rheticus based on different data sources and which are consumed by our cloud platform, fused, combined, connected with other open data, not only geospatial data, for the continuous update of indicators, maps, and reports. This way, we are switching from the traditional project-based approach in satellite data and geospatial data analysis to a new model of business, which is based on the subscription to monitoring service to the benefit of different markets, utilities, engineering, food, and governments. As you see in the slide, we have created lots of new smart maps for vertical markets. Markets with the private customers, markets with the governmental agency, and a lot of different applications, even for the B2C market, for the consumer market. The results of Rheticus can be consumed by smart maps, can be formatted in order to create automatic reports in the form of a PDF, which is easily understandable by a user, or through the APIs exposed by the Hexagon Geospatial solution, we can even feed third parties application. So we can consume the information created by Rheticus continuously into, for example, the ERP of our customers, of utilities companies. We will combine the information about the terrain displacement, the information provided by Rheticus about what is happening on the Earth surface, together with their common data workflow, common data management tools. This way, we can really address new markets in the infrastructure sector, in the energy, renewable energy, in the financing markets, which were a niche till the last years, but now can be the real new business opportunity for all of us. So let's have a focus on the utilities companies, the challenges they have. When they manage their utilities network, they always fight against problems and even collapses in their pipelines. In in cities like those we have in Italy, this can create a problem with the architectural heritage. They can compromise the public image of the company. They can even impact on the everyday life of the citizens, on the local businesses, shops, on the traffic, the urban mobility. And if we look at what happens to the utility company itself, they need to deal with the different materials and construction systems. They very often the lack of fresh and accurate information and all the variables they have to manage when a collapse in the pipeline is happening, which sometimes may cause big disasters. So they need to identify the problems before they become critical. How they are dealing with this today? The traditional approach is that they do the maintenance after the call from the citizens, after they know about the problems. So for them, it's difficult to define priorities. It's difficult to foresee the intervention time, the cost, because they do not know which are the areas in the city where they may have problems. And according to a study made by the European Association of Remote Sensing, these problems to the pipeline can have a cost of $180,000 per square kilometers, which for the US, for the entire US gas distribution means $9 billion of dollars. According to this study by ERSC, the benefits of services like those provided by Rheticus can be estimated at $2,700 per kilometer per year. And so let's see how we have addressed the problem of Gruppo Hera in Italy and how we have really helped them save money and time. Hera is one of the largest Italian multi-utilities. They take care of the environment with the waste management services, of the water in a different city, not only in the center of Italy, in the Bologna region, but also in other regions. They are in charge of the monitoring, on the control, the management of the sewage pipeline for 14,000, more than 14,000 kilometers in length, which is, as you can easily see, a huge amount of kilometers of pipeline monitoring. So what we're doing with the HERA, let's tell the story of HERA. They started 3 years ago with the Rheticus displacement over a test area of 300 square kilometers. So with Rheticus displacement, we highlighted the points according to our monitoring techniques where they had displacement problem in the terrain. This is what you see here is the web interface of the application, of the traditional Rheticus displacement application we provided to HERA. And for each dot, the red dots, you see they could see the trend in the terrain displacement. With this approach, working over a large area, they had, as a result, they could identify 15% of critical segment after the inspection, meaning that over 100 inspections they made of the field, 15 of this really presented a critical segment. We understood that for them, analyzing the problems in the area through the control of these red dots was not easy, even if, as you see in the slide, that had them to recognize subsidence problems in area where they did not expect such kind of problems. So it was really helpful for them, not only to identify critical areas in their utilities network, but also to have an understanding of the general problems of the area, especially where they have their plants. But then they were so happy with the solution provided that they extended the area to 3,500 square kilometers. This time, not anymore with the Rheticus displacement, but with the vertical solution, network alerts. Network alert is the smart map we created, which simplify the access to the displacement information for the users with an application, as you see in this video, an application listing the segments of the network which require an inspection. So segments to be inspected, and every time the users click and zoom on a specific segment, he gets information about the displacement trend. He can have a very easy understanding of what is happening in that area. So at the end, this is the very easy to understand information they need, and in order to address specifically the problems they have identified in their area of interest. Thanks to this, the critical segments they identify after inspection raised to 40%. Over out of 23 field surveys performed, they found 13 critical segments, where out of these 13 critical segments, some of them they had a high damage grade. So that was the real important results of this of the implementation of Rheticus network alert. They have improved by 40% the accuracy in the detection of critical segments, and this is already a great result. And this justifies the investment they made, even if it is a very low cost investment for the monitoring of their area of interest. This year, we are going beyond the services already successfully provided with the network alert, and we are integrating and connecting the information coming from the satellite data analysis, the information about the ground motion, with ancillary information like the materials, the pipeline information, the list and the geolocation of the historical repairs they've carried out, the water table, the ground, which provide information about the pressure of the water on the ground, and information about the traffic and local transport data, which of course are very important, as the pressure over the local traffic is also a variable which may affect the stability of the network. And we also integrate other ancillary data from the enterprise resource planning software of HERA. The combination of all this information into our network alert application help us to provide the predictive models which supports the predictive maintenance of the network. You easily understand that if we combine information coming from the space with information coming from the field, from the citizens, the calls from the citizens which inform about the problems in the network, all these big data mixed together, and with automatic algorithms for the recognition of recurrent patterns in the resulting from the combination of this data may help us to predict where it is more probable that they will have problems, so they can address their inspection with a better knowledge of what is happening in their area of interest. So with the combination of ground motion information from satellites and big data from the field, we go towards the predictive analytics creation for the predictive maintenance of the network. The Gruppo ERA has been so happy, as you see in this statement from Mr. Gelli, the head of the water depuration and sewage system of Modena, that they accept to be testimonials for the video which has been shown by Mladen Stojic, the president of Exxon Geospatial, during the last keynote held in Exxon Live 2019 in Vegas, and which has featured the big success achieved by Rheticus in the identification of problems in the network of the ERA group. Behind the scenes, the role of the M.App portfolio in this is crucial because, as you have understood, Rheticus is a platform we use to create the continuous flow of information, but then the M.App portfolio is the Exxon Geospatial solution we use to create the vertical application and to combine the satellite data with open data information coming from the ERP of the users all together to provide information, reliable information, and predictive analytics to the benefit of the users. We use the special workshop to create automatic recipes for the analysis of the data, and this way we are more and more creating applications we are really successful which are really successful in supporting the decision making process of our users in different field and in different countries. With M.App Enterprise you can provide services following different business approach. From one side, the traditional approach is using our smart maps created in our platform using Map Portfolio and fueled by Rheticus. So what you sell to the customers is just the username and password to log in to our web application, and we will update this on a monthly basis. Another approach can be if you have your own Map Enterprise, or if you deploy M.App Enterprise on the customer premise, where in this case you can customize the application, and with Rheticus we can fuel the application. So it's a win-win approach where we sell the content with Rheticus, and your customer, they subscribe to the content provided by Rheticus together with the purchase of the services, customization services provided by you. So this is the end of this presentation. I hope I helped you understand where we're going with the Rheticus, and the most important message to share with you is that today with the network alert, with the verticals of Rheticus, we can really solve problems. We can help our customers to save money, and more, this is already available, this is already working, and this saves money for the customers. We are more and more improving Rheticus as a platform in order to combine the ancillary data together with geospatial and satellite derived data, and this will improve more and more the reliability of the information we will provide. But together we will go towards the creation of predictive analytics for our users. Thank you very much, and have a nice day.